Question 2, maximum mark 5. The height of a baseball after it's hit by a bat is modeled by the function ht is equal to negative 4.8t squared plus 21t plus 1.2, where ht, the function h, is the height in meters above the ground and t is the time in seconds after the ball was hit. Write down the height of the ball above the ground at the instant it is hit by the bat. So let's just think about what's happening. Generally, there's going to be a a player, they've got the bat in their hand, the ball comes in, and they hit the ball, and it goes up, and it's going to come back down. We've got the height of the player to account for, but the height of the ball as it was hit by the bat is when t equals 0. So negative 4.80 squared plus 21 times by 0 plus 1.2, that's 1.2. The height of where the ball was hit is 1.2, and if you're thinking about reference of your height or where you would hit a baseball, it would probably be about 1.2 meters off the ground. Find the value of t when the ball hits the ground. So we've got the model here. This is the model that represents the height of the ball, and it's going up and then coming down. So once it leaves the bat, goes up, and it's going to hit the ground. So we're going to assume that it doesn't hit anything, that nobody catches it, that it just follows that trajectory and lands. So on our calculator, we're going to go to graph. We're going to type in the function, which is going to be negative 4.8. Now, the calculator works in x and y, so we have to input x as our function, as our variable rather than t. So that's 21x, and that's going to be plus 1.2. Okay, so we can see that the ball goes up off our screen and then comes back down. Just to make our lives easier to see this, we're going to change the window. We're going to have a look at the window settings. We know that the time can't be negative and the ball lands before 10 seconds. Height can't be negative, and we know the ball is going up from 1.2 meters. So let's say 50 meters. Okay, so the ball is hit by the batter, it goes up, it reaches the maximum, then comes down and hits the ground here. So we'll do menu, analyze graph, and we're going to go for a 0 this time. Okay, we're looking at this point, so we choose somewhere to the left of that point, somewhere to the right, and it tells us that t is equal to 4.43 seconds when the height is 0. So t equals 0 when t equals 4.43. Finally, state an appropriate domain for t in this model. Well, we've already had to use some of the domain. On our screen, we've got it going from 0 to 10 on the x. But a more appropriate model would be from when time starts at 0, from when the ball is hit, including that value. We can have t. And the ball lands at 4.43. So we can have less than or equal to 4.43. Perfectly acceptable to use inequalities. You could say it's the set of values with the curly brackets. But I think at this stage, inequalities done.